Okay. All right. So in this class, we are going to talk about another chapter. That's basically the 17th chapter. It's algebraic representation and formula. The format is going to be same. Initially, we will discuss the contents, and in the last 15 minutes, or in the last 20 minutes, we will talk about past paper questions from this topic. So let's get started. It is basically chapter number 17. Algebraic representation and formula. Okay. All right. So in this class, obviously, we won't be able to complete this chapter because it's a very big chapter, but we'll just start off with the basic idea. Now, I'm pretty sure most of you would be having an idea about what exactly happens in algebra, but still, for the sake of completeness, I'll start off from the scratch. Okay. So let me write down a term. Let's say we have 2x plus 3. In this expression, it is an expression, okay? It is an algebraic expression. And why is it an algebraic expression? Because I have a variable here, or because I have an alphabet here for you guys, okay? This alphabet right here is basically called the variable. It's just a name. Do not worry. It's called the variable. The number that is written with the variable is basically the coefficient, and this number right here that is coming without any term is basically constant. Okay, so at times all of us are clear with the idea, but still we are not familiar with these terms, and this is important because in the questions the examiner can ask you using some specific terms. So for that we'll have to answer accordingly. Okay, so this is just a basic idea. All right, now the next thing is the difference in 2x plus 3 and 2x plus 3 equals 0. This right here is just an algebraic expression, but this right here has an equality sign, so it is an equation. Okay, forget about quadratic linear for now. I am not talking about that. I'm just explaining that what is the difference in an expression and in an equation. In equations, obviously, we have the equal to sign. And when you have something without the equal to sign, that's just an algebraic expression. That is it. Okay. Then another thing is that let's say if I have 2a plus b plus c. So in this equation, I have three different variables. And in total, how many terms do I have? I have one, two, three. I have three terms. If I talk about this one, how many terms do I have? One, two. This has two terms. And again, one and two, this has, or forget about it. It has two terms basically on this side. Okay. So every term is basically separated by an addition or subtraction sign. And this is how we just, count the number of terms. All right. Okay. Let me write down a definition. That's very important. Polynomial. What exactly is a polynomial? A polynomial is an algebraic expression consists of one or more terms. Okay. So yes. Okay. What is a polynomial? A polynomial is just an algebraic expression and it consists of one or more terms. For example, 2x, it is an algebraic expression. Why? Because it has x. This is a polynomial. 2x plus 2, this is again a polynomial because it is algebraic and it has two terms. If I talk about 3a plus 4, this is also a polynomial. If I talk about 2y, so it said even if it has one term, it would still be a polynomial. And if I talk about 3a squared plus a plus 1, this is also a polynomial. So a polynomial is just an algebraic expression that has one or more terms. That is it. Okay. So this is just a random idea about some contents that I am pretty sure most of you would be knowing. Now let's
Uh,
talk about, yes.
Teacher, what is a term? I don't understand really.
Sorry.
The term. Like, what is term?
Term. Okay. Let me tell you. Okay. Term is just the different numbers or variables you have within that expression which are separated by a plus or minus sign. Okay. Now, since I'm saying plus and minus sign, this is one term. Then I have a plus sign. This is a separate term. And then this is a separate term. So these are three terms. Okay. If I say 2xy plus 8, this 2xy is one term because terms are separated by plus or minus sign. And this is a separate term. So this has two terms. Are you getting this?
Yes.
Okay, let me give you some more examples. Let's say now we have x plus y plus z. Forget about if it's a variable, if it's a number, it's just this. If we have different things coming with a plus sign or a minus sign, that is considered to be a separate term. So it's the first term, the second one, and the third one. This has three terms. And if I say x, y, z, this is just one term. I do not have plus minus sign here. That is separating my terms. So this is basically one term. Okay. This is the idea. Okay.
Understood.
Okay, all right. Very good. Okay, don't worry about the number of terms. That's something you would get better at it. And even if you were not able to understand it right now, it's completely fine. This would get better with time. Okay. Okay. Now let's talk about some basic algebra rules. Okay. The first one, I'll explain the rules by talking about examples. The first rule is basically this, that you can add or subtract the like terms, or you can combine the like terms. For example, let's say I have 2x plus 4 plus 2y minus x. What is happening here? This term is coming with x. This term is also coming with x. So what I can do is I can just simplify both these terms in order to combine them. And I can do that because the variable is same. So 2x minus x is going to be simple x plus 2y would come as it is plus 4. Okay. All right. This was part A. Part B is you have 3y plus 8x plus 11y minus 5x plus 9. Again, the idea is same. We can combine like terms. And how do we combine like terms? By first understanding which terms are same. If we look at the first term, it is 3y, and the third term also has y with it. It means that I can add these two. Okay, so this would become 14y plus, I have 8x minus 5x, so I can do 8x minus 5x, that would give me 3x plus 9. So this is how very good, Moise. This is how we deal with like terms. We can combine them. Okay, now one example for all of you, just so I know if you guys are able to understand all of this or not. Part C, it's for you guys, please do it. Let's say you have 5t. Now the variable could be a, b, c, d, e, f, g, h, i, j, k, l, m, n, o, p, q, x, y, z. It could be any variable. Okay, it could be any variable. So let's say if you have 5t plus t squared plus 2t minus 2t squared. Can you guys just simplify this? Yes, very good. Umaiza, excellent. Yes. 1 second. Okay, Umaiza, please make sure that you just recheck this sign of t squared, okay? And same goes for you as well, Ariba. Just check the sign. You guys do get the idea that you need to combine terms and which terms are supposed to be added together and subtracted together. But we know a sign thing, right? We need to understand that sign thing as well. That's also important. So I'll stay quiet for a minute. Just try doing it and then I'll get back to you.
Ma'am, was my question right? I mean, my answer.
Yes. Is this Hassan Sahal?
Yes, ma'am.
Yes, it's correct. Very good. Okay. Let's do it together now. So we have 5t, and which other term has t in it? No, not this one, because it is t squared. T squared and t are two different terms. Okay, very good, Moise. So we have 5t and 2t. You can think about it as two same terms and we can add them up. So 5 plus 2 would give you 70. Now we have t squared. Now this is another variable, t squared is another variable, and minus 2t squared is also t squared. So we can combine these two terms. Now how are we going to combine it? It's t squared minus 2t squared. So the coefficient is 1 here, it's 2 here. We know that we are going to subtract and the difference would be t squared. And what about the sign? The sign would basically be the negative sign because we have negative with the greater number. So it would be 70 minus t squared. Okay, please make sure that you understand the sign thing. That's very important now. Okay, well done, Taha. Very good, guys. So you know how to add and subtract like terms. Okay, so this was basically rule number 1. I'm not writing down rules because at times we're just comfortable with stuff and you people are not able to understand the definition. So math is not about definitions. It's just this, that if you are used to a rule, that's perfect. So you know we can add and subtract terms with same variable, and this is how we can combine them. Okay, let's talk about another rule. Now we are done with the addition and subtraction. Let's talk about multiplication now. Okay, rule number 2. Again, we'll discuss that through examples. Let's say you have 4 multiplied by 10x plus, not plus, and then this is multiplied by y. So how do we do it? It's very simple. You are just supposed to multiply the numbers with numbers. 4 multiplied by 10 would give you 40, and we will write these variables as it is together. This would become xy. Let's talk about another example. Let's say this time around you have 10a multiplied by a squared multiplied by 2. So we are going to multiply 10 and 2 because these are the two numbers. This would give you 20. And what about a multiplied by a squared? First of all, I will write it as a multiplied by a squared. And I know that even this is correct, but since we have studied indices, so we know the
A
property.
cube.
Yes, very good. That when two numbers are being multiplied and when the bases are same, the powers can be added and we can write it as one number. So this would become 20a cubed. Okay. Then let's talk about another one. So here we have 12 multiplied by 2x multiplied by 3y. So first of all, multiplication of all these three numbers, it would be 12 multiplied by 2 multiplied by 3. We are just supposed to multiply these three numbers first separately. And this is going to be 24 to 3 is 72. And then we are going to write down the variables as it is. So it's x and y. Very good, Moise. Okay. This is basically the idea behind multiplication. And then under the same bracket, we can talk about division as well. So if I talk about division, it would be 40xy divided by 2y. Now please pay attention. This is the question. What we can do is we can just cancel these terms and I can just cancel this separately and I am left with 20x. Okay. If I talk about another example, here I can say that I have 2yt divided by 10yx. Again, I can cancel numbers with numbers. So it's 1 times and this is 5 times. I can cancel variable. I cannot cancel t and x. So the answer is going to be t divided by 5x. Very good. Muiz, excellent. Okay. And one last part for you guys. And this is going to be 10x cubed y squared divided by 5xy. Please take your time, use the indices rule, and then tell me the answer. Yes. Umaiza, just check the sign. Your first sign was correct. Yes, yes, yes. It's correct. It's correct. Very good, Umaiza. Your answer is correct. Well done. No, this is basically for power, okay? It's, you are right. Your sign is correct. This is not for square root. It's for power, okay? If you're writing the sign and then you're writing around a number, that means that The number has that power. Very good. Okay. Excellent. So most of you were able to do it correctly. Let's see how to do it now. First of all, I am going to cancel out numbers with numbers. This would be 2 times. Next, I am going to talk about the variable. So I know indices when two bases are same and when the two terms are being divided, what I can do is I'll just cancel it here and I'll subtract 1. I'll cancel it here and I'll subtract 1. And this would give me 2x squared y. So this is going to be the answer for this one. Very good. Okay. All right. Another concept is basically this. That if we have 5 multiplied by a squared plus 2a plus 4, now this 5 is coming outside. I will multiply 5 with this term, 5 with this term, and 5 with this term. And I would get 5a squared plus 5 would be multiplied by 2a plus 5 would be multiplied by 4. And this would become 5a squared plus 10a plus 20. So this is going to be the answer. Okay. Let's talk about another part for this one. Very good, Muiz. It would be 2 multiplied by 10x plus 2t. Again, 2 is written outside the brackets. I'll multiply it with this term. I'll multiply it with this term and this would become 20x plus 4t. So we were able to multiply it directly. Okay. And just one last thing, then we'll talk about past paper questions. What if you have 5t plus 10 and you've been asked to factorize or simplify? So how do we do it? How do we factorize? We can factorize by taking out the common numbers and common variables which are coming in all the terms. Okay. So I have 5t and I have 10. What number do I have common here? 5 is common. I have 5 here and this is 2 multiplied by 5. So I will take 5 common and I can write it as t plus 2. Okay, let me talk about all the examples for this one and then you guys would get clear, don't worry. For the second one, let's say it is 10x squared plus 5x plus 15. Okay. Which alphabet or which variable is common in all 3 terms? Okay. So x is coming here, x is coming here, but I don't have x here. So I can't take x common. Let's talk about numbers or the coefficients. So every coefficient is basically a multiple of 5. So what I can do is I can take 5 out and I would be left with 2x squared plus x plus 3. Okay. This is how we do it. Whatever number I'm taking common, I'm supposed to divide that by all the 3 terms and this would give me the answer. Yes. Are you guys able to understand this?
Yes, understood.
Okay.
Yes, ma'am.
Okay. All right. That's perfect. So I think now we can talk about the past paper question.